Salvi, Assistant Professor, Department of Pharmaceutics, Smriti College of Pharmaceutical Education, Indore. So today we are going to start with the main second point of pre-formulation studies, which was your solubility analysis. In solubility analysis, we had discussed about the pKa, constant determination, then solubilization techniques. After that, we are going to start with the topic dissolution, or you can say dissolution rate profile determination. So what is dissolution? Dissolution rate of a drug, substance or any excipient in which surface area is constant. The surface area, which is denoted by capital A, that is constant during disintegration, and this phenomena is described by the Noyes-Whitney equation, which is dC upon dt equals to capital D, capital A, small h, capital V, Cs and minus capital C. In this equation, dC upon dt is dissolution rate, then capital D is diffusion coefficient of drug in dissolution medium. Into the dissolution medium, the concentration of your API or drug, which is denoted by capital D. After that, small h is thickness of diffusion layer at solid liquid interface. So what is the meaning of solid liquid interface? If this is a drug and when we will put this drug into the medium, this is liquid. So at the surface of solid, when the liquid get adhere, this is known as the solid liquid interface, or you can say the surface of solid when liquid get contact is known as solid liquid interface. So small h is thickness of this layer. Then capital A is the surface area which is exposed to dissolution medium. Surface area means what? The surface which is exposed or which is in direct contact with this liquid is known as capital A, that is surface area. After that, capital V is the volume of this dissolution medium. Then Cs and capital C. Capital C is the concentration of drug or API into the dissolution medium or the solution at time t. And Cs is the concentration of saturated solution. Solution which is already saturated at the experimental temperature. It is denoted by Cs. When we will put this area capital A constant, and when the C, capital C S is greater than C, then the equation would be dC by dt equals to d Cs H upon V. This would be your dissolution rate equation. Through this equation, we can find out the dissolution rate of different drugs and different raw materials in pre-formulation studies. After that, when we will perform the dissolution rate study, so generally what happens when we will use tablets for the dissolution rate determination or to determine the rate profile of different drugs. So in diesel apparatus, there are two type of diesel apparatus, type 1 and type 2. Type 1 is basket type and type 2 is paddle type apparatus. So when the drug is light in weight or drugs which can float onto the surface of medium, so in that case we go for the basket type of dissolution apparatus, and in other cases we can use paddle type of dissolution apparatus. So what is the process of determination of dissolution rate profile? So this is the flask or dissolution flask. As per IP, the requirement of dissolution is we have to fill this flask with 900 ml fluid. The fluid could be your phosphate, buffer solution or distilled water or any other solvent which is specified into any drug monograph in IP. So this is the this amount is fixed, 900 ml of fluid. So when we will start to heat this outer liquid of chamber until the temperature get up to 37 degrees centigrade, we will on this instrument, and when the temperature will reach at 37 degrees centigrade, we will place our tablet into the sample. Then after specified time interval, we will withdraw sample. For example, if time interval is 5 minutes, 10 minutes, 15 minutes and 20 minutes. So this is the different time interval. In this time interval, we will get 1 ml as a sample. We will withdraw sample from the dissolution flask and we will replace this 1 ml with the fresh medium to maintain the sink condition. Then when we will take this all samples, we will find the concentration of this samples through UV spectrophotometer. Then this concentration could be in microgram per ml or mg per ml. So if the concentration is microgram per ml, then we have to convert this microgram into mg. Then this concentration, where we will find out the concentration, we have to multiply this concentration with the dilution factor. Dilution factor, this is 900 ml, and further if we had made dilution of these samples, then we have to add that dilution also into this dilution factor. So after this we will get the concentration of drug into mg, or we can say that after 5 minutes this much concentration, this much amount of drug or API get released into the body. Then we will convert this amount into the percentage. If we had taken this tablet of 500 mg and the concentration after 5 minutes we will get 5 mg, then we can say that 1% drug is getting released after 5 minutes. So likewise we will plot the graph into time versus percentage drug release. As the time 5 minutes, 10 minutes and 15 minutes. Along with the time, the concentration of drug into the body continuously will get increase. So this was the dissolution phenomena. In next lecture we will start with the stability analysis of the drugs.